there, it just says you can add or subtract like radicals. So like radicals, it's basically what it is the radical has to have exactly the same expression underneath, and they have to be the same type. So like I can't add a square root and a cube root, but you can add two square roots as long as they have exactly the same thing underneath the square root. Or you could add or subtract two cube roots as long as they have exactly the same thing under the cube root. So what you do here, I promise this is not hard. Look at the two radicals. So this says, and this is kind of complicated, right? But we're not going to simplify anything here. This is 7 square roots of xy, 3 square roots of xy. As long as these are like literally identical, which they are, they're just square roots of xy. Those are what we call like radicals. Exactly the same thing. They're both a square root. All you do, you don't change anything with the radical. Just take the numbers in front and add them in this case, or subtract if you're doing subtraction. So this would become 10 square roots of xy. That's literally all you have to do. Okay, now, can I subtract, if I do 2 cube roots of x minus 2 cube roots of 5, can I subtract those? No, so that's already simplified. I can't do anything else there. There's nothing to do that problem. Can't actually subtract those, so that's already simplified. This one's tricky. If I have, on that last question in that row, I've got 8 cube roots of 9 minus the cube root of 9. Can I subtract those? What do you think? Exactly. I think these can be tricky. This kind of has like a little 1 in front of it, like a -1. So don't forget that when you do that. So this would be 7 cube roots of 9. All right. What about 7 fourth roots of 5 minus 2 fourth roots of 5? Can I do that one? What would I get? 5 fourth roots of 5. That's all you're going to do. Just 7 minus 2. You don't change the index. You don't change the radical, remains exactly the same. All right. What about 2 square roots of 7 plus 5 square roots of 17? If you could break down, but 17's not going to break down, so that's already simplified, so I'm not going to do anything else there. There's nothing for me to do. What about 4 cube roots of 5 minus 10 square roots of 5? Okay, it's not meant to be mean or anything, but that is a cube root of 5, and that is a square root of 5. So if they're a different index, they're not like radicals, so actually that expression is as simplified as it can get as well. So they're right there, you got 3 problems. You wouldn't even have to do anything. You just have to recognize they're not like radicals. Is anybody having a question? Okay, now, what we're going to mix in are these problems right here at the bottom in example 2. So initially when you look at the problem, it's not going to look like you can add or subtract because all the radicals will have different values underneath, but they're not simplified. So if they're not simplified, you actually want to simplify each of the radicals in the problem first and then see, okay, do we get like radicals if we simplify them? And then maybe we can add or subtract depending on what our simplification is. So let me just start with this one. Can anybody tell me biggest perfect square that'll divide into 20? 4. All right. What about biggest perfect square that'll go into 45? 9. You guys can talk. It's cool. All right. And this one's always tricky. Anybody know biggest perfect square that'll go into 80? 16? Yep. All right. So I'm just breaking each one of these down, and then I'm going to take out any of the perfect squares. So that's the whole reason you want to find the number that'll multiply underneath there to give you perfect squares. So square root of 4, that's going to come out as 2. Square root of 9, that's going to come out as 3. Square root of 16, that's going to come out as 4. Now, if something's already in front, which I do have for a couple of these terms, and you pull something out, you're going to multiply them together. So that first term, 2 times 3 is 6. So that first term, all simplified, is 6 roots of 5. Now, there's nothing in front of the next term except a subtraction sign. So I pulled out a 3, so this would be minus 3 roots of 5. And then the last term, excuse me, I had a 4 in front of it, pulling out a 4. So this will actually multiply to get me 16 roots of 5. So initially, when I looked at that problem, I didn't think I could do it. But if I actually simplify and put them in simplest radical form, they are all like radicals. They're all roots of 5. So you literally just take and add or subtract the numbers. So like 6 minus 3 would be 3, plus 16, we'd have 19 square roots of 5. You don't change the radical, you don't change the index, you don't put like 15 under the square root or anything like that. You just take and add or subtract the numbers that are in front of the radical if they're like radicals. All right, now this one will be trickier. These are cube roots, so I don't know that you guys are as super familiar with these. You're not breaking down 2 under a cube root. It's not divisible by any perfect cubes. Let me lay this up here. So that third column I'm looking for. Tell me the biggest perfect cube that would divide into 16. 8. All right, so, and these can get tricky, so make sure you're paying attention. So I'm going to rewrite this as 8 times 2. That's 16, right? All right, now, the last term I have 9 cube roots of 54. If I look at that third column there, does anybody know that this is a little tricky? It's 27. So 27 times 2. And if you're like, what the heck, Miss Scrody, like, how am I supposed to know this? I would literally, there's only a couple numbers you'd have to check. So if I'm looking at that third column, and I know this is not true, I'd just do like, okay, is 54 divisible by 8? It's not, because I got a decimal. Is 54 divided by 27? For sure. There it is. It's 2. And then like 64 would be too big. So if you're not sure, it's really fast to check, and there's not very many numbers to check. It has to divide into it. And so once you're there, though, now we're in a cube root situation. So that first term, I didn't simplify that. That was simplified as far as it could go. That second term, cube root of 8 would pull out as a 2. That third term, cube root of 27, would pull out as a 3. So if something's in front, we're going to multiply it. So that first term, I still have 4 cube roots of 2. That second term, we're going to do 7 times 2. So I got 14 cube roots of 2. And then that last term, I have a 9 in front, so 9 times 3 is 27, and then cube roots of 2. Once you're there, we're literally just adding or subtracting. These all end up being like radicals if we put them in simplest radical form, so we can combine them. So I'm just literally like -4 plus 14, and then minus 27. And I typed something wrong, so let me see what that is, -17. Don't change the index of the root, and don't change what's under the root. Just the numbers in front, you just add or subtract. Is anybody having a question? Okay, I'm going to do the fourth root with you, and then I'll let you guys try the last one, which is the cube root. All right, so fourth root, I need the biggest number in that fourth column that'll divide into 32. There's only one number to check, right? It's the 16. So 16 times 2. All right, 162 under a fourth root. Anybody know the biggest perfect fourth that goes into 162? 81. So it's 81 times 2. And then the last one, yikes, I got 512. So let's check that out. So 512, there would be 3 numbers I could check. So I'm going to divide that by 16. Whoops. Hold on, let me pull that down so you can see it. Okay, now, 16 does go in. Let me just check and see if any of them, because you want the biggest perfect fourth that you could do. So I'm going to just check if that's divisible by 81. No, because I got a decimal. And I'm going to check 256. And that's 2. Okay, does anybody know how I knew there would be a bigger one that went in than the 16? Okay, I'm just going to back up on my calculator here. When I did that first step, right, I did 512 divided by 16, and I got 32. If I have a number on that list that'll also go into what I got, so I got 32, 16 also goes into 32. So I knew there was going to be a bigger number that I could use. So that's why I kept going on that. So 16 went in, 256 goes in. You want the biggest perfect fourth that you can find, just to save yourself some time, because if I had broken it down with the 16, we could have simplified it a second time and broke it down again. So I'm just trying to get the biggest perfect fourth. All right, so 16, fourth root comes out as 2, 81, fourth root comes out as 3. Be really careful, because 81, 16, 64, they can appear on a couple of the lists, so make sure you're using the right list. So on my fourth root, it's 3 to the 4th power is 81. And then that last one, we're going to pull out a 4. All right, anything in front, we're going to multiply. So that first term is really all simplified, 20, 4th roots of 2. Second term is minus 18, 4th roots of 2. And then the last term is plus 12, 4th roots of 2. So when we simplified all of them, they end up being like radicals. They're all 4th roots of 2. So if I combine those, 20 minus 18 would be 2, plus 12 would be 14, 4th roots of 2. Okay, you guys add and flip on over to that. We're going to do some multiplication and some addition here. Okay, so some of these are really quick and easy. Some of them might just take you a second to do, if I can get it on the screen. The very first one, you can always multiply radicals as long as they're the same type. You guys will notice on the entire back of this, these are all square roots. There's no cube roots on the back of this at all. So what I'm going to go through and do on the first two, we're just going to do a literal distributive property. So I'm going to take 3 roots of 7, and we're going to multiply them by both terms in the parentheses. Now, on that first term, I got 3 square roots of 7 times 4. What you do there, just multiply the numbers outside. So 3 times 4 is going to give you 12, and you just write the square root of 7 next to it. That can't be simplified at all. That's as far as you're going to be able to go. You can't break down what's under that radical. Now, the second term, I have 3 square roots of 7 times the square root of 7. As long as they're the same type of root, they're both square roots, you can multiply them together. In that situation, you just keep the 3 out in front. Now, with the square roots, when you multiply them, square root of 7 times square root of 7, just squish those two numbers together with multiplication under that radical. So 7 times 7 is 49. If you multiply a radical by itself, it should get you a perfect square, which is what I got going on here. So this is 12 roots of 7. This term is really, when I take the square root of 49, 3 times 7. So it's 12 roots of 7 plus 21. Now, I would totally take that as an answer. What I want to tell you really quickly, though, the preference would be, in that situation, if you have a plain number, like I have the 21, put that in front of the term that has the radical. And the reason that's a little bit more accepted notation is only because sometimes people get confused and they'll think like that plus 21 should be under the square root when it's not. So I would take either one of those answers, but if you can remember, if you got a plain number, just put that out in front. You cannot add those together because you don't have like radicals. You have a 21, which doesn't have a radical, and 12 roots of 7. So that's as simplified as it can get. So I would take either answer, but if you can remember, try to put the plain number in front. All right, let's try this one. Now, we're going to multiply square roots together, so we might have to simplify something. So I have a little -1 times the square root of 8, which the square root of 8 is not in simplest radical form, but that's okay. Let's just go ahead and multiply. So we'd have a little negative in front. 8 times 2 would make that first multiplication. Just a little negative times square root of 16. Okay, the second term, I'm going to do negative square root of 8 times negative square root of 10, so that would actually turn into a plus. Now, with the radicals, they're both square roots. Just do 8 times 10. We're going to squish them together underneath, so that would be 80. This first term ends up being a perfect square. That's really just -1 times the square root of 16, so -4. And then if you can, I think we had an 80 on the front, actually. Sorry to repeat that, but if you can break the radical down, you want to do that. So biggest perfect square that goes into 80 is 16. It's 16 times 5. So I'm just simplifying this a little bit. Pull the perfect square out, so I'd pull a 4 out in front, and then we'd have -4 plus 4 roots of 5. And just please, 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 I see people do this sometimes. They'll accidentally take the two numbers out here and be like, oh, -4 plus 4 is 0. Don't do that. This is -4 by itself. You can't add it to a term that has a radical attached to it. It'd be like -4 plus 4x. You wouldn't add them together. Is anybody having a question? Okay, now, if you are going to multiply together, I've got 8 plus the square root of 11, and then I want to multiply that by 1 minus the square root of 11. Anybody have an idea? Like, how would you approach that next question to multiply that? Anybody know? What do you think? Do what? Do what? Yeah, FOIL, exactly. All right, you just don't have any variables here. You're just gonna FOIL. You can always multiply. If you're a person that likes to draw a box, just draw yourself a little 2 by 2 box, and the terms would be 8 and radical 11, and then 1 minus radical 11. Now, you can multiply all of these. So 8 times 1 is 8. Now, if you do 8 times that negative square root of 11, I just put a little subtraction sign, and then you just put the 8 in front and let the radical 11 follow. When we do that, the reason for that, put the number in front. Again, it's just so you don't think like the 8 is underneath the radical with the 11. So just put that in front. Now, this term, square root of 11 times 1, probably would not see the 1 in front of that. But if you want to write it in, that's completely fine with me. They'd probably just write that as the square root of 11. The last term, you have a positive times a negative. So positive square root of 11, negative square root of 11, that's going to be a minus. And 11 times 11, if you multiply a square root by itself, it actually will create a perfect square. So that's going to cancel out. And then the reason we were doing what we were doing on the front, in this question, you've got some like radicals kind of in the middle there. So really, I have 8, and then I have negative 8 roots of 11 plus 1 root of 11. So it would be minus 7 roots of 11. And then this last term here would be negative 11 because 121 is a perfect square. The only other thing you can do there is we can put the plain numbers together. So I've got an 8 minus 11. You can just go ahead and do that. So you're negative 3 minus 7 roots of 11. And then just don't put the negative 7 and the negative 3 together. Those are two separate terms. That would be my answer. All right, now on this one, don't distribute. Do not distribute that exponent, okay? So if you are squaring something, anytime you have adding or subtracting, if you square something, you're multiplying it by itself. So really what this question is asking me to do is root 2 minus root 3 times root 2 minus root 3. If you distribute that exponent, you will get the question wrong because you'll completely miss out on the middle term. So write it twice if you're squaring it, and then go ahead and multiply. So I'm just FOIL, box if you like a box. You can always multiply radicals together. They don't have to be like to multiply them. You just squish them together under the same square root. So root 2 times root 2, that first term would be square root of 4. That's going to be a perfect square. All right, square root of 2, this is minus square root of 3, so I'm going to put a subtraction sign in between. 2 times 3 would be a 6. That does not break down under square root, so we won't have to simplify anything here. Now, I'm going to get negative root 3 times positive root 2. So I get another negative square root of 6. Those do not cancel out. They're both like a little negative 1 in front. And then on the end, negative root 3 times negative root 3 is going to be positive because I've got a negative times a negative. And when I'm multiplying a radical by itself, we should get a perfect square. So that's going to cancel out. All right, now, square root of 4 is 2. So that's that first term. Square root of 9 is 3. That's that last term. In between here, these do not cancel out. You have a negative 1 and another negative 1 in front of those root 6's. So with my plain numbers, we got 2 and 3. That's going to be 5. And then it's minus. You have negative 1 here, so it'd be negative 2 roots of 6. And when you add and subtract, don't forget, don't change what's under the radical. Don't change the index. It's like negative x minus x would be negative 2x. This is negative root 6 minus root 6, so you got negative 2. All right. Now, this next one's kind of tricky because I've got some radicals that are a little bit gross in this one, but this would just be like a little FOIL again. All right, so I'm going to take 2 times both of those terms, and then we're going to take 4 roots of 6 times both of those terms. 2 times 1 is just going to give you 2. Now, 2 times this negative 5 roots of 6, you're going to multiply the numbers outside together. So I have a plain 2, and I have a negative 5 in front of that, so it'd be minus 10 roots of 6. Then I'm going to multiply 4 roots of 6 by both those guys. 4 roots of 6 times 1 would just be plus 4 roots of 6. Now, the one on the end is probably the most complicated. On the outside, I'd have a positive 4 times a negative 5, so it'd be a negative 20. And then you'd have root 6 times root 6, which is root 36, which is a perfect square. So for this term on the end, you're really just going to have a plain number because I'm going to take the square root of 36. So I have 2. In between here, these guys are like radicals, negative 10 roots of 6 plus 4 roots of 6, so we can actually combine those. This would be negative 6 roots of 6. Then on the end, that term is really negative 20 times 6, so it's really negative 120. The only other thing you could do there is actually combine that with the 2. So you'd have negative 118 minus 6 roots of 6. Is anybody having a question? That one's really hard. Don't put the negative 118 and the negative 6 together. Okay. Now, this very last example is going with what we're doing today, but what I'm going to make a little note of, do you guys see on this last question, these are identical except one's a plus and one's a minus between the two terms. I don't know if you remember this from first semester, but these are called conjugates. They're exactly identical, but one has a plus and one has a minus. Now, the reason I'm just pointing this out to you, we're going to use this a little bit more tomorrow, but we're just practicing the multiplication today. What's going to happen here is going to be interesting on this question. So let's just FOIL this out real quick. So root 5 times root 5, root 25. Root 5 times negative root 2 would be negative root 10. Then I'm going to do root 2 times root 5. Both of them are positive, so it would be plus root 10. And then on the end, now, whenever you have conjugates, this last term should always be negative because one of these is a plus and one of these is a minus if you're working with conjugates. So a positive times a negative is a negative. Root 2 times root 2 is root 4. All right, so this first term is really just a plain 5. This last term is really just a minus 2 when I take the square root of 4, but it should be subtraction because I had a negative times a positive. And what's interesting about this, these guys in the middle are like radicals, but one's plus, one's minus. They cancel each other out. So really, I have just 5 minus 2, which means my answer is 3. So we're going to work more at this tomorrow, but whenever you multiply conjugates, all the radicals cancel out. So if you get a question like that, don't think you're doing